For years, scientists believed that life on Earth began around 3 billion years ago. But now, new fossil evidence suggests that simple but diverse forms of life may have existed far earlier, and as much as 4 billion years ago or more, which, if true, is very soon, geologically speaking, after our planet itself developed. It's apparent evidence that could have major implications across a wide range of areas, from evolutionary biology to the definition of life and even in our search for aliens. This is Unveiled, and today we're answering the extraordinary question, did scientists just discover the oldest fossil of all time?
Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content.
Really, this story starts back in 2008, when researchers from University College in London unearthed some unusual rocks in a remarkable area of Quebec, Canada. The team came across an ancient layer of sediment calculated to be between 3.75 and 4.28 billion years old. It was ancient land that had once lay on an ocean floor, and upon further study, the researchers saw that some of the rocks had unusual impressions in them. Interesting shapes like tubes and swirls. And so, although this rock and sediment was far older than any fossil ever found before, it was suggested that the shapes could still have been caused by ancient living organisms. Organisms that, if they did exist, would throw the timeline of life much, much further back. Led by Dr. Dominic Papineau, an expert in earth sciences, details of the findings were eventually published in the journal Nature in March 2017, which instantly triggered debate. Had the UCL team merely found some strangely shaped rocks and come to the wrong conclusion? Or were the impressions really of living things? Was it then possible that life had developed here so much earlier than anyone had previously thought? If so, it would certainly have a tremendous effect on the field of biology. Before this discovery, it had been generally accepted that the oldest fossils on Earth were only 3 to 3.5 billion years old, and therefore it was thought that microbial life had not been prevalent on this planet until that time. Rocks found all over the world map, in Australia, Greenland, and South Africa, for example, contain fossils of bacteria, microbes, and simple worms from long ago. But nothing else found is quite as old as the UCL rocks from Quebec. There's a gap of hundreds of millions of years between them and all other fossils. And in the end, scientific consensus erred toward perhaps a safer solution. That although the impressions in the rocks were intriguing, they didn't constitute direct evidence of ancient life, and that they could potentially have been formed by chemical, not biological processes. Dr. Papineau and his team didn't give up their study, though, and narrowed their investigation down to just one rock about the size of a fist. They sliced it into thin sheets with a diamond-edged saw and observed the shapes under different kinds of microscopes. They even had a supercomputer create digital 3D pictures of the inside of the rock, using X-rays and focused ion beams. And by the time the team published a new article in the journal Science Advances in April 2022, they had gathered far more compelling evidence that the rock did indeed contain fossils left by living organisms. For one thing, the shapes within the rock were found to be even more complex than they had first appeared. For example, in some cases, there was a long stem shape with seeming branches like a tiny tree, which could not be explained by any form of chemical reaction. Also, traces of mineral byproducts were found that could further link these shapes to something that had once been alive, even all those years ago. Despite the further and seemingly stronger evidence provided by the group from UCL, however, there's still some debate as to how these impressions came to be. There are still some doubts as to their true origin and even surrounding the hypothetical biological somethings that might have made them. Which leads to a further question. If, say, the fossils weren't created by organisms recognizable to science today, then what did create them? One of the age-old questions of biology, which perhaps has still to be satisfactorily answered, is what is life? How does one define life, and how can you distinguish between living and non-living things? At first glance, this may seem easy. Living things use energy, they grow, they reproduce. And all those definitions have been presented before. But the trouble is, when you look deeper, you'll find that many supposedly non-living entities do the same things as well. Rocks take in heat energy, then release it at night. Minerals change over time into different substances. Water grows and contracts with changes in temperature. Computer viruses reproduce. even to the point where variations occur. Elsewhere, in a famous experiment of the 1950s, the chemist Stanley Miller created conditions in a glass globe similar to the atmosphere of early Earth, added water, heat, and electricity, and ended up with organic molecules, amino acids, the building blocks of life, but also perhaps not what most people would consider to be living things. What's your verdict? Are they living, or is there still another jump to make? The point is, it's not always easy to tell just what is alive and what isn't. Somewhere in the course of evolution on Earth, there must have been a transition between what we consider chemical and biological processes. Obviously, this shift from non-life to life would occur before any organisms really got going, perhaps hundreds of millions of years earlier. If Dr. Pepino's team haven't discovered ancient fossil evidence of recognizable organisms then, they might have found something that's actually even more amazing, evidence of what's called prebiotic evolution, meaning the transition of mere matter into life itself. In this way, the UCL fossil may have been created by something previously unknown, and something that could lead us to re-examine our definition of life again. Just as archaeologists occasionally debate the exact species of a hominid skull or whether an extinct creature was technically a dinosaur or a bird, is it possible that fossil evidence might be able to capture a snapshot of the before and after moment between inorganic matter and life? It would be a moment where life was so simple, so different from modern organisms, that we really could have trouble telling whether it was alive or not, which might be what's happening here. This discovery could then have major implications in our search for extraterrestrial life as well. If life developed this way on Earth, it may have done so elsewhere too, and in similar places. Life-seeking planetary expeditions of the future could use the UCL data to target locations as smartly as possible. NASA's James Webb Telescope, which can gather information on the chemical makeup of faraway celestial bodies, is sure to be of some use in showing astronomers precisely where to look. Also, the data seems to show that organisms developed more quickly on Earth than previously thought. It arguably makes the basic idea of extraterrestrial life, simple extraterrestrial life, generally more plausible. Many planets have had much more time in existence than Earth has, and some under similar conditions to foster the first steps, at least, toward the development of diverse living things. It might be said then that these fossils give us new hope and new clues as to where we should be looking for aliens. However, we must not make the error of assuming that life elsewhere would necessarily be similar to life on Earth. If it's already difficult enough to define life here, then would we still even really know if we had found it somewhere else? In this, again, the UCL study may give us clues. There's evidence, for instance, that the possible microbes in just that one rock derived energy from a pretty wide variety of sources: iron, sulfur, carbon dioxide, even light. Though not through photosynthesis, as Earth's oxygen boom hadn't happened yet. There were options then, and seemingly a number of different paths that the very earliest microbes could have taken. We just need to work out what those paths were. We shouldn't necessarily assume that smaller means simpler either. It may be so in this case, but as the author Michael Crichton theorized in The Andromeda Strain, evolution could follow a different route again, a route like computer technology, toward smaller and more efficient, although equally complex organisms. Altogether, it's quite a remarkable little rock that Dr. Papineau and his team have picked up. While only about the size of a billiard ball, it holds a tremendous amount of fascinating evidence. Signs that diverse, though simple life on Earth may have existed millions of years before anybody thought it did. Indications of how and where it developed, and intriguing suggestions about what life really is. And that's how scientists may have just discovered the oldest fossil of all time.
What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.